Recording? All right, it is recording. Okay. Well, I am back. I want to actually start this game here. We're gonna make a tic-tac-toe game in my own editor that I have done up here at colinglover.com/dev. I guess we'll assume that you've watched the last video already. If not, you should check that first, where I go through the editor and show you what all these buttons are for and give a rundown through of how it works. But I'm going to use the editor right now, and we're going to show you how to make a canvas game, how easy it is. So let's dig right into it. First off, all we have now is just a basic HTML page here. In order to work with canvas, we will need a canvas tag. So let's start with that. And we're going to give it an ID so that we can actually access it, so that JavaScript can access it later. So we'll just do that right now. And as I hopefully mentioned in the last video, the only thing that goes between the canvas tags is the message for when canvas doesn't show up. And this is basically all that's got to go here. Why do I not have any syntax highlighting? What did the break did? Oh, there it is. Okay, not sure what that was about, but I'm not restarting the video. All I done was put in the canvas tag. Okay, now I'm back to where I was. So that's basically all that needs to be done for the HTML part. I might come back here later for something else. Well, I will be coming back here later for something else, but it's not important right now. So the next thing is, if we hit run, we don't see a whole lot in the screen here. We're gonna go under CSS here and add something so we can see our canvas, or at least identify it from the background. So we're just gonna do that's for the ID. And we can do a border. Let's see, 2 pixel wide border, black and solid. How about that? We'll hit run here, and now we can see the area that our canvas occupies. So this is where we're going to build the game. Actually, I'm going to kind of make it square a little bit later, once I push over the JavaScript. Alright, so we don't need that. We'll keep the debug and echo functions here. We can ignore those for now. They were explained earlier in the other video. So what we need to do first off is to set the size of the canvas. That'd probably be the best place to start. I'm not making this up as I go. I do have a cheat sheet over here. Just trying to find my spot here. Alright, well, let's first off start with letting JavaScript know where the canvas actually is. So we'll set a constant for the can. So the document refers to the HTML, the context of it anyway. Get element by ID. This is the ID right here that we gave the canvas. It's ID equals can. So we'll just go back to JavaScript. And can. And this lets us refer back to the canvas. And the next constant we should do is the context. This is where we actually can do stuff with it graphically. It's just another layer. There's other layers. There's a 2D layer and a 3D layer. There might be some other stuff too. I'm not entirely sure right now off the top of my head. So we'll refer to the can that we just made. This part here is this part right here. We're referring back to this. So we'll get the context. And we're going to do this in 2D. If I hit the right letters. 2D. Alright. So that lets us access the canvas from JavaScript. So in order to set the width and height, very simple. We just do a can equals, what do we want? About 500 by 500. Can dot width 500. Again, if I hit the right keys, that should give us a square canvas when I hit run here. And 500 by 500 seems kind of excessive for the scale that I have my screen at anyway. So we'll lower that down a little bit again. There we go. That's a nice square. That's all I need to see here. And yeah, JavaScript doesn't really care about white space. Everything could all be on the same line. It's just the only reason you space it out with the indentation and all this stuff is just so that you can read it easier later. Since they're basically the same statement for setting the size, I'm just going to leave it on the same line. So moving forward, what does the tic-tac-toe game have? It has a crosshatch, pound sign, for the grid. So in order to do that, we should make a function to draw that grid. Functions are used to repeat code over. If you're constantly doing something, you don't have to code it every time. Like, if you're doing an animation, you don't want to have to code in to redraw the frame each time. You kind of just do it in a loop through a function. So you can execute it as many times as you want later. So we'll do up this function for drawing the canvas. We're going to want to draw the grid. So we just list our functions. It's kind of like a batch file for anyone that's done any sort of programming or messed with batch files or shell files if you're on Linux. Depends on what background you're coming from here. So we're going to have to take the CTX, and since we're using 300 by 300, we can do this two ways. We can actually make the computer do the math, or since we know that we're using 300, let's go back to the iframe. We know that this is 100 and this is 100, and the grid's going to be at 100 each. So I mean, we really don't need the computer to do the math for that. So first off, since this is going to be a function for redrawing the canvas, we're going to clear the frame. We're just going to hard code it in. Since tic-tac-toe doesn't really need to resize, I will be just hard coding in. So we'll start at 0, 0 for the clear, which would be the top left here, 0, 0. Right there where the mouse pointer is. And we're going to go down to 299 by 299. The reason for that is because we start at 0. If we started at 1, it would be 300 by 300. But since we're programmers, we start at 0. So we're clear the rectangle first. And we're going to need to draw a line. That would be a CTX. First, we have to move the cursor into position. So we're going to let's go back to the iframe here. It's going to start at 0, 0, so we're going to want to move it to 100 across. And 0, we're not going to go down any, so it's going to be 0. So it's 100, 0. Move to 100, comma, 0. And then we do a CTX dot line 2. And if we're going to start at 100, comma, 0, which is roughly here, we're going to need to go down to here, which is also 100 and 100 over and 300 down. Not sure why that didn't turn blue, but then again, neither did clear rect. So from here we could also do a line width, basically the thickness of the line. We're probably going to want that decently visible. We'll make it 4 pixels. And if I was to hit run here now, it would not be very impressive because we're not calling the function. This function doesn't get ran until you actually run it. By the way, the functions should also probably be put up in the function section. The constants can also be put up in the variables section, global variables. I have these sections listed out here just to keep the code tidier. Guess those can be global too. They're not necessarily variables as such, but they can be global. They're not going to change. Alright, so the actual code, we just want to call the function first off. Draw can is what we called the function. And there are no parameters here. So it's just draw can with 2 brackets and the semicolon. And now that should draw my first line. But it did not. The reason it did not is because we didn't call the stroke command. We just positioned the stuff. So we do a ctx dot stroke, and that actually draws the stroke. Should probably set the color of it to, which would probably be a good idea. It might default to black, but we'll. But we'll set it anyway. So we'll set the number sign there, and the colors in hex format. The first 2 colors are red. First 2 numbers are for the red. Next 2 are for the green, and the last 2 are for the blue. And they're in hexadecimal. And you can grab these actually from the help section. So the red, that's a red, green, yellow, orange, and so on. It'll give you the number there. And we got the stroke color to black, and now if I hit run, I should see the line. Why is this not working? What did I miss this time? Well, if you run into this problem, all you have to do is make sure that the function itself is getting called. That's the first thing you can do. And the best way to do that is to, since I have a debug function here, we'll set a timer, 1000 milliseconds, and some text. So if it is actually calling the function, I should see hi come up when I run it. And hi does not come up when I run it. So if I hit F12, I'll see all this stuff over here in my debugger. And if there's a lot of stuff there, the easiest way to do it is to clear and then hit run, and then you'll see where the error is. And it says ctx.linewidth is not a function. All right. That is correct. It is not a function. It is a more or less variable. And there we go. There's our first line. And now we just put in the code for the rest of the lines. We don't need this debug anymore. We know that it's being called. If we can leave the console open here, that way if any other errors come up, we'll see them. So we keep this. We'll put that there and we'll keep, and then we'll copy this. So we need 4 lines total, 2 across and 2 down. We'll copy it 4 times. Actually, we don't need line width copied 4 times either. That is a function. Okay. That's the way it needs to go. These only need to get called at first, set everything up. And then these are the ones that actually draw the line. We'll copy those, paste those here, and then we'll change this to 200, 200. That means it goes over 200 and goes down from 0 to 300. So that's 2 lines down. I can run it and show you. We have the 2 lines down there. Next are the 2 lines across. Basically, we're going to be not moving to the right at all. So it'll be 0. And we just basically reverse the numbers. And we'll paste the other guy in here. We're going from 0 to 300 at 200, 200. So that should give me a hashtag if I've done that right. There we go. There's our tic-tac-toe. The grid anyway. So that's the function for drawing the grid. So every time we call that, it'll erase and draw the grid. I actually don't think we need to erase as much in tic-tac-toe because it's an additive game. Not much comes back out of it, but you need to know how to do the functions anyway if you're making your own game. And the next function we need to do up is to actually draw the letters on the screen, the X's and the O's. So we'll do another function for that. We'll do that as a separate function. It could actually be done in the draw function since it's such a simple game, but we'll do it as a separate function. All right. We'll call it draw text. We got draw can and we got draw text. Now with the draw text function, we're going to need to be able to describe what letter goes in here. And we're also going to need to describe the coordinates that they go at. So X, Y, and L should cover what we need to do here. Okay. So we can do this two ways. We can actually manually draw out the letters. X's and O's are pretty simple, or we can use the font function. I'm just going to go ahead and use the font function. And use actual X's and O's. So we'll ctx.font equals we'll try 100. Gotta put it in quotes. 100 pix Tahoma. Tahoma is a good font for this, I think. At least that's what my cheat sheet says. And the color, yeah. Gotta capitalize the S for the hump notation. That's what it's called. Like humps on a camel. It shows up more when you have all small letters. Okay, anyway, ctx.fillStyle equals, and we'll also make that black. 0, 0, 0, the absence of all color. And we're gonna need to take ctx.fill text and we're gonna have to put it at X. We're gonna simplify this. So this is 0, 0, 0, 1, 0, 2, and all the way up to 2, 2. We're just gonna identify these by single numbers, and we're gonna make the JavaScript do the math. We'll go X times this times, right? Yep. 100. And that should put it in the right spot. It might need to be tweaking it a little bit because there's font. The fonts don't coordinate the same way. But I'll check that later. Comma Y times 100. Actually, I think the text goes first. And the text should be under L. Alright. So that should be that function. So if we done a raw text and we want it to be at 1, 1. Numbers don't need to be in quotes, but anything that's letters or not numbers actually should be in quotes. So we'll make this the X here. Put that semicolon at the end, and if I did that right, should put an X at 1, 1. It did put the X at 0, 1 actually. That's supposed to be 1, 1. That's 0, 0. So the font must be needing a plus 100. Okay, and that puts it in the right spot. It's not centered. So in order to center it, I'd say we need to add, we'll just guess, manually centered. We'll say it needs to be an extra 40 over, and we won't move that 100 down, we'll move that 60. Woo! That was a bad guess. There we go. That's closer. Close enough. The way this works, I think, is that the center point for the font is right here. Not the center, but the point that it works off of. So instead of putting it right here, this would have been the 0 times 100. That's why the X showed up here. So I added 100 and it went down here, but then I had to slack it off a bit and then push it over. But this is the point that the text works off of. So everything text-wise goes from this point and goes over. So if I added extra letters, they'd appear after that. Alright, so that lets us put text on the grid. Now, what we need to be able to do is not put text on the grid manually. We would like to be able to point and click to do that. Now, currently, there's nothing here set up so that we can click on an element. If we go back to the HTML, we can add an on-click. Now, HTML doesn't require any capitalization whatsoever. So in JavaScript, you'd probably do on click. In HTML, it doesn't need to be done. So we'll do mouse click. We'll make a function called mouse click and get JavaScript in a bit. And we'll call the function the parameters that get passed through as event. We can figure out where the click was. And that itself does nothing until we actually program the function to take care of that. Function mouse click. Oh. Yeah, this automatically puts some things in at the end, like when I was typing canvas at the beginning there, it automatically typed canvas at the end. Function mouse click. Oh, I'm gonna need a variable there. And put a letter there so that we can grab the data that's coming from event. We'll just call it E. Right, so when it clicks, we're gonna want to draw we'll take this draw function that we already got done here. We're gonna want to draw an X when we click. Now, in order to put the X at the right spot, we're going to see where our mouse pointer is clicking first. E dot. So we're going to set up a debug so we can actually see what E is printing out. Actually, we can let's just see what all of E prints out first. We'll comment out the draw text. We don't need it to do that. We'll just see what E itself prints out. And hit run. It just says object mouse event. Nothing useful to us directly. But the actual code that you need offset X. And we can also offset Y. And just so the numbers don't run together, we can put that there. All right, so that should give us the X and Y coordinates that we were clicking at. Okay, it didn't exactly put it on the same line. But yeah, if you notice I click up here, it's closer to 0, 0 as I can get it. 1, 1. Yeah, well, there you go. Going by pixels is hard to click on, and up here would be 299 by 299 or very close to it. Yeah, there it is. So you can see the pixels that you're clicking at. Now, this needs to be translated so we know which box that we're clicking in. Because this does not translate to the 0 by 2 grid that we have here. Or 2 by 2 grid that we have here. Alright, so now we know how to pull the mouse functions out. So we're going to want to XX equals and var YY equals alright, now if we done just that, when we go to click, it'll just place it right there at the mouse cursor, at that corner point that I was showing you earlier. And run, just to prove my point. Why did it no work? Oh, yeah. Because these are supposed to be between 0 and 2. That's why it didn't work. When I put those actual numbers in, it's showing up somewhere else. So we need to make those. Divide it by 3, I think. Where we were going with that. And that should give us the raw numbers of roughly where they should go. But not exactly. Nope, still nope. Oh, yeah. Let's actually learn math here, people. We have to divide it by 300 to get the fraction. And that'll give us what we need. Yeah. But it doesn't put it where we need it. So what we need to do, find out what numbers we're actually getting when we click. We'll just double check the XX and YY. Okay, so that's a 0, 0, but there's lots of extra stuff. That was a 0.5. 0, 0, and a 0.6. So the numbers are still kind of low, aren't they? There we go. That's what we're looking for. But it still places it at the cursor. I didn't do the plus. Alright, but it's still placing it at the cursor. Why I needed the extra. Actually, let's not do that. In order to get it to place it at the cursor, you gotta get rid of the decimal point. See, it's 2.03. It's gotta do some rounding basically. So we'll move from there. In order to do rounding in JavaScript, it's depending on what way you want to go. We need it floored, the lowest number, so that if you click anywhere in this area here, it gets floored down to this point, which is 0, 0, and that's the number that we need. So floor. Math.floor is the function we will be using. And that will, math that has to be capitalized. And that will, wherever we put the mouse cursor, we'll put it in the right spot. And that's how we do that. But that really doesn't help much. Because it's a pretty one-sided game at that point. So how do we keep track? Well, the easiest way to keep track, the computer doesn't see what you do on the grid or remember. It just remembers it as a graphic. The easiest way to do from here is to make a variable, an array actually. variable as an array. And arrays are usually done up brackets like this. And since it's a pretty simple one, we can actually fill it out beforehand. It's a 3x3 array. We got 3 across and 3 down, so it's 3x3. So inside this, put some empty strings. So there's the first array. Second array, that's the third array. So there's 3 empty strings, 3 empty strings, and 3 empty strings, all wrapped in another array. That's a 2-dimensional array, which is 2D, just like our canvas. And what we do is when we go down to the mouse click, when we actually draw the letter, we can go to grid. We can assign grid. This is the X coordinates go first, and the Y coordinates, that's not how it goes. That's how it goes. And the Y coordinates. So in the array grid up here, whatever button we click on, it'll put it in the array as it looks on the actual image. So that way the program knows where everything is stored. So at XXYY, and we're also storing, let's do a capital X. And that's how we can store our move. And one more thing we can do is after the math is done, we can check to see if we actually click there. If grid at that point, XY equals blank, blank, oop, then we can execute that. Else, if it's taken, we'll just put out a debug message saying that it's taken. All right, so this is an if statement. Basically, if the condition matches what's defined here, it'll execute what's in here. If you put an else after it, it'll do that instead. So if I run this now, it'll print the coordinates, but if I click the same spot again, it'll say square taken. Because it knows that we've already put something in there because of our variables. And then from here, what we need to do is set up and make the computer pick a square. And the easiest way to do that is to check the squares The easiest way I can think of right now actually, we'll do this even simpler. We'll make a for loop. We'll learn another thing. Just let me type this up here. Alright, so this will scan across y. Let's do y first. Y equals 0. Y is less than 3. And y plus. Alright, this creates a loop. This statement right here between this spot and this spot. Yeah, I can use y. Y is fine. So this creates a loop. It starts the loop at 0 and then increases it by 1. Y plus plus means y plus 1. I mean, if you wanted it, you can even type it out to y equals y plus 1. It's the same thing. As long as y is less than 3, it'll keep executing this loop. X equals 0 as long as x is less than 3 and x plus plus. Alright, so it's gonna scan through. We'll copy this statement. So if the grid is empty in that spot, we're going to, we haven't set up this array yet. We'll set it up in a bit. Okay. So let's set up this array first. We'll start here, then I'll turn is a blank array. This we're gonna make a function that lets the computer know what spaces are available. There's probably easier ways to do this, but this is the simplest way I can think of right now to tell you guys. So first we'll make a blank array, or blank the array. Actually, the array will already be blanked every time the function goes through, but we'll blank it anyway just to be sure. It's going to start at the x's. That's the most inside of the grid. It's going to go across from x0 to x2. And for each time it goes through, it'll check to see if it's blank. If it's blank, then it'll push the coordinates, which would simply be x plus y. Now, if I just done in the x plus y, it would add the two together. It's basically 0 plus 1 and 0 plus 2. We don't want that. We need it as a string still. We have to stick a string in between it so it doesn't add the numbers together as numbers. It's just one of the quirks of JavaScript. And when that for loop runs, both of them together, after it does this line of x, it'll increase the y by 1, and then it'll run this again. So basically, runs through this line of X, increased by 1, then this line, and then it checks this line to see what's blank, and then it pushes into the turn array the X and Y coordinates. So right down here at the end, all right, now there's enough brackets there. All right, what you do is hover the mouse over the cursor here, and it highlights the ending bracket just to make sure everything's closed up right. So your if and your fors should all have closing brackets, and this is at the beginning of the function. So after that loop is done, what we can do after that is check to see if there are any moves left. So if it comes back with nothing pushed into the array, then there's basically no moves left. So we'll run this check here. Basically, if the length of the array turn equals 0, nope, 0, then we'll put the debug. We'll just use debug. D-E-B-U-G. And we'll keep it up for 10 seconds. That's in milliseconds. That's why there's so many zeros there. And we'll just call it no moves left. So when there's no moves left, the game will know. So if we run this now and actually test it, see it plots the points over there that I'm doing. And if I do them before the timer runs out, it just adds it to the end. And then boom, no moves left. And square taken and no moves left. So if we want the computer to make a move here now, we'll do it when there's moves left. I'm just checking here to see where we are in my script over here. All right, back to it. All right, so we went and made a variable called CPU. And we'll get it to choose a move. It's I'm not going to get into making it a really good player. We're just going to make it make a random move. So we're going to use a random function. Math.random. The way random works is kind of weird. It gives you a float number, a decimal number, and you have to multiply it by turn not length. You have to multiply that by the number that you want to be random in between. And that should pick a random turn for the computer. And the and scroll up here enough where we actually made our move. That was our draw text function, right? Yeah. We have to make it O. And we need the substring. Or charat. Charat works too. Okay, so CPU is going to pick a number. We need not grid. Need turn. Trying to keep track of all these variables in my head here on the fly. So we need to check the turn value. Turn array. Everything got pushed into the turn array. We have to check the turn array at CPU. CPU is the value of the CPU chose randomly. And we need for the, what did we put first? Y? Okay. We need the first character. That should be char at 1. Y was put in there second. And X needs to go first, so that's actually position 1. And then there's a char at 0, because Y is position 0. Now, in theory, that should make a computer move as soon as you make yours. Unless I made an error. Missing bracket after statement. Missing bracket after statement. I don't know a bracket, but there's definitely a dot missing there. There we go. I can go here. And I can go here. I'm not sure why the computer didn't just play after I made my last move, because it should still play because it wouldn't have detected that. But as you can see, yeah, I don't know why it just stops moving randomly. I'll look into that code. I'll have to look into that code a bit later, because right now I'm just going to stop and we'll continue this in part 2. In part 2, we'll add a bit more to this. So I'll just leave it here for now. And maybe I'll put the code somewhere so that you can take a look, or you can just follow the video along. Probably the best way to do it is just follow along with the video and type it out. You could pause it and type it out as you need it. There's not much there anyway. Probably easier to learn it if you type it out yourself rather than Just copying and pasting what I had there. So yeah, just pause the video if you need to. There's not a whole lot written here. And just hit run and you can play with it. Like I said, in the next video, I'm gonna look into that bug and we'll finish up the game a little bit more. Thanks for your time. I'm out.